So I will say a few things about what science is all about. And certain things which are implicit but not really talked about as to how science moves forward. So let me start from there. If you see, science is not just application of logic to the world around us. Many times one feels that science is about the application of logic. So you construct a logical structure. Many times people also confuse science with nature, phenomena. As phenomena, things are happening out there, and then what is science? So when I have been thinking about this question, science is basically human take on the world. How we understand the world in terms of motives which we can communicate to other human beings. And of course, logic is a very important part of science because you need to build logical structures to understand the world. That is a scientific way of looking at the world. However, logic has its own difficulties. I don't know whether you people have taken a course on logic and on philosophy and all that and so on. First of all, two logical structures could be equally logical. That's even n logical structures can be equally logical. Then how do you choose one from these? And that way one will get stuck. So science has another pillar that when you have done enough struggle with logical structures and when you have two competing or three competing logical structures, you actually do experiments with the phenomena about which you are talking about. And from there you decide which logical structures are valid scientific hypotheses and which are invalid. So validity of logical structures in science is checked by actual laboratory or nature experiments. So that's a second pillar of science. And this is how science progresses fast. Because by the way, this whole question of logical structures in science and quick progress of science and what science is all about was analyzed in detail by the philosopher named Francis Bacon when he was talking about quick progress of science in 300 years. And he argues that logic is a very old invention. We know logic for thousands of years. But then this combination is very, very important. Then there is a third pillar, which is a hidden pillar of science, which I think is very important when we transact with science as students or faculty or working scientists. That is that how do you agree upon something? Because nothing can really be proved or verified, and logic part can be verified, but the experimental part happens in one laboratory or the other, this, that, and so on. What is good science? What is bad science? So science is a collective human activity, and therefore it is the peer group. So it is the people working in a given field who validate each other's science. So this is sometimes we miss that. And we don't wait for the ultimate verification. Verification is a peer, it's a guild, it's a group. So whatever is done by scientists is immediately seen and understood and reacted upon by fellow scientists working in that field. And they are the ones who validate and say that this is good, this is very good, this is a great piece of work, field has progressed. So I always say that science is a strong structure because it has three pillars: the logic, experimentation, and guild or the peer group of scientists who validate each other's work. Now, this, for example, is valid for science, but this is not really valid for mathematics. In mathematics, we don't do experimentation. The other two parts are there. The logical structure part is there, the peer group and the guild part is there. And many times the second, what I said is the third part, which in science we don't talk too much about, the group or the guild. In mathematics that becomes very important because the part 2 is missing. So many times the trends in mathematics are set by whims and fancies of great mathematicians. But in physics and so on, it's very difficult because at the end you do experiments and you work with nature. So that's one thing I wanted to mention. The second I thought of mentioning was that in the Indian context, it's important since all of you are science students wanting to become scientists, I suppose. we are not combining our way of life with our professional activities in science. So many fellow scientists, when I meet them, you see, if you are running a shop, you are a shopkeeper, that's a profession. And your own worldview could be very different from the transactions which happen in your shop. You're a banker, you're a banker. But people who are working in any field where they are engaging with the process of creation of knowledge and developing pushing the civilizational boundaries of knowledge cannot oppose this, that their own lifestyle or their own thinking does not engage with it. So these three pillars of progress of science, a true scientist should also apply to life situations while transacting oneself in the world. But many times one sees that there is a gap in the worldview of the scientists and the worldview of science, which is used in the progress of science. Of course, one can still do good science in courts without really being scientific in one's approach. But then that somewhere I think a contradiction would be reached. So that is the second thing I thought I will mention. The third, I thought I'll tell you a little bit about myself. Many of you are new. So, I work in quantum physics broadly in the area of foundations of quantum mechanics, because quantum mechanics is not fully settled theory and not a settled structure. So, there are many interesting paradoxes and contradictions and so on which people come up with. That is my primary interest. And along with that, since something very interesting has happened in the past 25-30 years, that quantum mechanics is a success story. It was developed in 1920s, and by end of 1920s, the current structure of quantum mechanics was known. And for a long time, we have been applying quantum mechanics to various phenomena, and that has been great because we have understood particles, and we have understood forces, and we have understood field, we have understood materials. We have understood all kinds of phenomena at different time and landscapes. However, the logical structure of quantum mechanics was taken for granted for its applications, and its deeper implications were not explored earlier. So currently, in this whole era, where we are looking at logical structure of quantum mechanics and applying that to technologies and computing and cryptography and all that. So therefore, I also work in that area of quantum information or quantum information processing. These are the kind of things I do. And my third research interest is physics pedagogy, in which I have been developing experiments for physics teaching. So maybe one of these days we can bring all my experiments and I can show them to you. Some of them are there in your labs because many of these were developed wherever you see developed in the physics education lab, IISER Mohali. Those are all developed by me and Dr. Arvind. We used to collaborate in experiments, and we have developed many experiments. Some of them are in your lab, some of them are not in your lab. But that's another interest I have. As a research interest, serious research interest. And I also like public engagement. I've been talking about science to students at different levels, to also teachers and so on. And I was the first faculty member to join IISER Mohali in August 1st, 2007. The institute was just 6 weeks old at that time, and there was no building, there were no structures. So I have been very organically associated with IISER Mohali. However, past 3 years I was not here. So many of you don't know me because I had gone to Punjab University on a 3-year deputation, and I have come back in April 2024. In terms of my education, I studied in a village school, then I moved to a college. Those days 11th and 12th used to be in a college. Then I did my BSc, then I went to IIT Kanpur. From there I went to Institute of Science Bangalore. And then I have taught here, I have taught at IIT Madras. Before that I was in Guru Nanak Dev University, Amritsar, and then I was also at Carnegie Mellon University, Pittsburgh for 2 years. So this has been my trajectory. One last thing I want to say before I close. I have said 15 minutes, I will not speak for more than 15 minutes. See, what happens is that undergraduate programs are undergraduate programs. You come here very young after school, and I have seen best example is Chandan. Chandan came here, he was a very dreamy kind of person, he came after 12th. Now he has left after PhD and he's also done a postdoc. So, I mean, I've seen people grow from the age of say about 17, 18 to their mid-30s and fully develop the scientists and all that. However, what I want to say to you people is that it's very difficult to know when you finish your school what you really want to do in life. Because, quite frankly, the most important thing to know in life is what is that you want to do. And that is not taught. That is not even explored in our school years. So, therefore, but that cannot be an excuse. So, slowly we all learn and find out through a self-exploration what I really want to do or what I don't really do. Now, these years are very important when you come after school and you join an undergraduate program. These 3 years, 4 years, 5 years are very important. There is no crime in concluding that I don't want to do science. No crime, because you want to do science, don't want to do science. But it's very important to figure out in these years what you really want. Because once you know that, then you will be able to develop yourself around that. And that is one level, science, no science. Within science, physics, chemistry, mathematics, biology. Within that, certain interdisciplinary areas. Within physics, so many areas. So, over these years, you should develop this decision tree. Where I am and where am I going. And that is very important. You will see that over 2-3 years, you will know what are the things you like, what are the things you're good at, what are the things you want to do, how to build this energy and move forward. This exercise if you do, and this, by the way, this discussion is also part of that exercise. It's an exploration. Summer projects is part of that exercise. Various other interactions you have with people, with peers, with other students is part of that exercise. So, you people must dream. That's another thing I always say that in India, particularly, it is a bit unfortunate that we want to move from quick things to quick things in terms of career progress, this, that, and so on. Behind that should be that dreaming capability, which should not be lost. And you are in a premier institution, you all are doing very well, you must have done well, you have certain passion. So you can dream big. All dreams don't come true. But that whole idea that you have to live with a dream all the time, the dream might even be changing as you go along. It could be changing dream, need not a fixed dream. But at a given time, having a certain passion, having a certain dream is very important. And exploring what I want to do with an open mind. I tell you, opportunities will come your way. You should never try to normalize your interests based on opportunities. I tell you, when I joined PhD in 1991, everyone told me, work on superconductivity. If you work on quantum mechanics, you will not. Okay. I did what I wanted to do. Situations also changed. By the time I finished my PhD, actually since quantum information came along, it was not at all difficult for me to find jobs, but people who did a lot of work on superconductivity because high temperature superconductivity theory did not go very far. People could not draw wires of superconductors. That area actually kind of died. So, I'm not saying one should not do superconductivity. If one was doing it for the passion, that's equally important. But if one was thinking, oh, there are more opportunities there. So, those kind of practical things can come later. But at a deeper level, you must follow your passion. And before that, you must kind of be reflective enough to see what is your passion, what you want to do. So with these 3-4 introductory remarks, I will stop here. As they say in my profession, you ask a professor to speak, he will speak forever. So anyway, so let's stop here and now we take discussion questions, whatever is on your mind.
They say like standing up on the shoulder part of the giants. Like I want to ask like who is your like giants who you have?
Well, very standard giants I would say within physics as you know. I mean, there are people like Galileo, Newton. All these are giants. After that, of course, Einstein. In my field, people like John Bell, people like Aspe, Mendel, so many people. These are the people, the names which come to.
So you talked about how following your passion worked out well for you. But isn't there a certain level of survivorship bias involved in that thing? Because yeah, you followed your passion and you went into a field which didn't look so promising financially. But it worked out well for you. But there might be hundreds of other people who went into similar fields.
Let me answer. See what happens is.
Those fields.
No, I get your question. I am not saying that if you follow your passion, you will be very successful. What I am saying is, let's look at two situations. You follow your passion, and you get some less opportunities in life, you struggle more. You don't follow your passion, and you maybe get some quick success. When you will be middle-aged, in which situation you will be happier? See, suddenly, a game changes. Once the years pass, and you are in your early 40s, mid-40s, you begin to see where I am, how happy I am. So, don't go by one example. There are now papers written about people who went into IT industry very happily because they got very good jobs. And by the time they were mid-40s, most of them were frustrated with their lives. As I say in a very broad sense in the Indian context, that in this country, we have put in bright minds for mediocre work. And of course, they will be frustrated. Most of the software work is for reasonably intelligent people, not for extremely creative people. So if you put your brightest people in mediocre jobs, they will be frustrated. So following passion can, I didn't say I was successful. I had my difficulties also. All I want to say is that if you follow your passion, your happiness quotient remains higher, which is very important in life. After all, many other things one does thinking this will lead to happiness. Of course, you have to find your own course. It may be that materially successful is your passion. Very good. Then it doesn't matter what field you choose and what. As I told you, there are many walks of life in the world where you can divide yourself into two parts. Your activity which leads to your earnings, and then what you do with those earnings. Science, unfortunately, is not that kind of an activity. That was the research. But anyway, if that is the idea, there are much simpler things you can do than science. And earn a lot more money. Then why, as they say, in the lighter way I'm saying, if you want to make money, what is the best way? What is it? See, we live in a capitalist world. You agree or you don't. In the capitalist world, there are ways and means people use to make money. So who make most money? Who use only money to make money. They don't touch it. They work with finance capital. Fund A, Fund B. They actually have gotten rid of all in between media. They don't deal with money. Anyway, we are not talking about making money here. We are talking about science. Yeah. Go on. Idea was to listen to you. Yeah.
Sir, if you have interest in different kind of fields,
Yeah.
can you change your stream after days, like you have done something on this,
Yeah.
now I am wanting to do something on absolutely opposite direction, like because I am finding it interesting and what I read there in my previous years, I was finding something interesting and now when I'm wanting to start it again. So is this possible in that?
Yeah, a very good question, I must say. That this is precisely where one has to think very seriously. See, at young age, it's important to explore many things and that can be done quickly. Nobody will prevent you from doing one summer training in pure mathematics, another summer training in physics, third one in biology. At young age, it's of course easy to work in diverse fields and opposite fields. As you grow older, as you are more invested in a field, changing fields becomes difficult. But people have done that. It comes at certain cost also. But if one is really passionate about things and wants to do something different, there are so many examples of people who have switched fields and they have switched fields successfully. It's possible, but difficult. As you grow older, it becomes more and more difficult. It also requires certain courage. Because in the new field, you are like a newbie, people don't recognize you, your authority, but that's fun also. you become a student again in that field. So that's actually can be very interesting. Yeah.
When we have like two choices and it's equally likely for us to choose any of them and we equally like both the things, so then how
So that's again is a question I posed to one of my mentors, Professor R. Simon, who retired from Institute of Mathematical Sciences. Very fairly well known and actually great physicist. I will get him here to give a talk. Very non-trivial thinker. So when I had to take certain decisions, I discussed with him. And he gave me a very interesting way to look at decision. Let me share that with you. It's not my own. I have polished it up a little bit. It was a long conversation. I will summarize it. He said that when do you really have this vacillation between choices? When both the after all, what is a decision? He said there are weight. So there are so many things you have. There are weight factors. So decision is a weighted average over options. Alright. And if there are two options for which weight factor is almost same, then only for an intelligent person, then only it's a problem. Otherwise, it's very quick. A, B, C, A, because A clearly. So he said when you have such competing things, when you disagree, it's very difficult now to make a choice between two things. Then comes that you have to actually go back and change the weights you have assigned. And that has been a great lesson for me. Because then it is no longer that you are taking a weight. No, you go back and change the priorities you associated with each one of the options. And then your decisions will move. So you have to go one level better. So you can write it down, it works out very well when you actually put in the weight factors and you first force yourself to put the weight factors in a way that both come equal. Then you wait a few days and then you stop it. Which weight factor I will choose? And that is your actual decision making. It will also a good idea when you speak, you tell me which batch, name, I may not remember, but I'll have some idea. So which batches are represented here? How many are from 24 batch? Oh, many. Okay, good. 23, 22, 21. Okay, so all batches. So as they say, 24 is most curious. Good. As they say, curiosity goes down as we grow older. Yeah.
So from what I've heard so far about you, you are one of the top researchers in your field in this country.
Well, thank you for your compliment.
From your position, where do you see the research scene in India heading in 1 or 2 decades? Will we be able to compete with developed countries in terms of research quality and output?
Okay, that's a very interesting question. See, depends on what exactly do you mean by competing. See, interesting pieces of research come out of Indian communities as in coming from Indian community all the time. So, current challenge, the IISER was set up 15 years ago to increase the base of science, have more scientists working on various things, so on, because it was realized that we have not supported and funded basic sciences enough. So this will definitely have an impact and we will move forward in a bigger way. However, the policy maker seems to be confused and is not really taking the project all the way. Because if you ask me, another time we can talk about what exactly should be done to move forward. Because when the concept notes were written, people said, all right, you see, in 1940s, people who got their undergraduate education in India, they got Nobel Prizes and all that. Where are we now? This, that, and so on. So, in brief, I would say that science before Second World War was fairly individual activity, so you could create around you enough to be world class. After Second World War, science became a much more organized activity, and therefore, only if you have world class institutions, then you can produce world-class science in large volumes. So that's where we are, I think, struggling. We need to have more institutions, more organized activity, more sustained activity. So you see, many times you are young, so you don't know. In Indian institutions, one person retires, an institution doesn't even know what to do with his lab. So we need to kind of build in more robust structures to do bigger science. Of course, one thing we have done very successfully is created IISER, which bring in young people and expose them to science. And I think some very good science is going to happen through you guys. So that's in the next few decades. So we seem to be doing well in that front. But how to organize it into a bigger activity is the matter on which God needs to be. Yeah.
So my name is Amir Ashraf, I'm from MS24. So my question is, you were discussing the philosophical approach to science. So what I could gather is basically we look for patterns in nature, and then through our peers and through experimentation we get that verified. But isn't there an underlying assumption that there are patterns to look for?
Yes, that's true. And that assumption has been successful because we have been able to find those patterns. A nice question actually. So if you refine this question further, there are patterns and there are patterns. So for example, when Einstein says that God cannot be playing dice with the world, he feels that patterns have to be deterministic. And if one is seeing anything non-deterministic in nature, that's not a pattern we are after, and that is a lack of our understanding of that phenomenon. So randomness is also a pattern. So lack of pattern also is a pattern in some sense. So you are right, but that one is looking for patterns and one is assuming that there are patterns. And that assumption has been vindicated by the progress of science.
But so what if as we progress, for example, we started with the whole classical physics and then comes the modern physics, and we have been progressing. But what if we reach at a certain place where we see that the patterns that we are looking for, they aren't just there?
Good, then we'll start again. Well, that will be great. Like for example, let me give you an example. We have been talking about expanding universe. And the paradigm was that this expanding universe is expanding outwards, all galaxies are going away from each other, and there are three possibilities. This is well documented over the decades, people thought so. Depending on the matter density, either universe will expand forever and keep expanding, or it will expand and stop in infinite time. That's like, it is just critically poised. And third one is, it will expand, it will come back. So people thought there are three models of the universe, and by measuring the matter density, we will arrive at one of these. But then now we know that it is not just expanding, it is accelerating outwards. We don't know why, so we are back to the square one. We don't know whether it is a fifth force, whether it is something called dark energy, whether it is a repulsive aspect of gravity. So this happens. So the pattern which we thought was a very good pattern falls through fingers.
So, but what if it's happening for no reason?
No, patterns are not reason. See, reason, the logical structure or the reason part is our construction. Okay, so that's our construction that we see a certain, well, you're talking about maybe causality. So, still, there is a cause and effect relationship between many things. But if you have to accept randomness, which means there are things which happen beyond that reason also. And reason part could be one part, and the non-deterministic part could be another part. That we have already seen in nature. What you're saying. Earlier people thought that it's very important to have a deterministic causation. But you're right. Those people have now seen patterns which don't seem to be deterministic causation. So we have already learned to live with that. And that's why even somebody like Einstein was so uncomfortable with this aspect, that there could be non-deterministic patterns. But whole thing cannot fall through. Why? Because we have meticulously, experimentally validated those patterns. Their domain, their validity can become limited. They can't suddenly, that's the whole strength of science. The entire edifice cannot fall through. Modifications and all that can be done. That's the difference between many other structures to understand the world, which can fully fall through. So science that way is an incomplete ever progressing understanding of the world, but as you said, standing on the shoulders of giants. We don't let go. We prune, correct, move on. But whatever has been validated in a certain domain, in that domain, that validation remains.
So that's assuming that the laws will not change and things like that, right?
So that's what we have seen. So if we see changing laws, there will be a pattern to the change also. That's also possible. But we have not seen where in the time in which we have developed science, or whatever construction of the past we have done, we have not seen change of laws, other than, for example, the inflationary period of the expansion of the universe, where we certain new laws have to be brought in and so on, which they later on no longer needed. But in principle, laws could also change, and they may be changing, but then there will be a pattern to the change, or are they changing randomly, or it's a combination of patterns, random patterns and non-random patterns.
But what if, sir, it's so random that there is no pattern?
Alright, if we encounter that situation, we will deal with it, but does it look like it? It's possible. It's a logical possibility, yes. Then we'll all become, those wanderers who just observe, see, and be contented. Don't try to interpret. It's a possibility. Apparently, the world doesn't look like that. Yeah.
Recently, I think we all know about the news about the Nobel Prize that a molecular biology professor got by doing machine learning and Nobel in physics. So, and there are countless other interdisciplinary things coming up. So, when the lines between disciplines are so blurred, how are you expected to know what exactly you want to do? Like, you're supposed to be choosing a physics or chemistry major. When it is so interconnected, how do you know exactly how?
Yeah, so finally it is the questions that you deal with, and many of those questions turn out to be interdisciplinary. And that's why in IISER we believe in a broad-based education. I've been talking to some of the very successful early graduates to get their feedback. And they all say that we might be working in a highly technical, theoretical area in physics, but the biology and the chemistry and the other things we learned at IISER, they remain at the back of our mind. So that's, I think, that's what that courage he was talking about. One should have the courage to begin working on the question which really interests you, even if it is not in your area. But yeah, you're right. Did say, as another, I'm forgetting the name, I should not try to take credit for other people's ideas. So I will, it's again not my own, but see, disciplines are created to organize knowledge, not to become hurdles between the cross-fertilization of knowledge. It's just that human knowledge is very broad, so it needs to be classified. At the end, I mean, one should not be bounded by one should not be considered as a bound. The disciplinary boundary should not be taken too seriously.
Sir, could you just give us a brief of what is the field of quantum information? And
Some other time, it will have to be a full talk. Maybe one of my students can give all these, many of them are in my class now. I have given them a semester long course, and whoever gets maximum marks in the course should come and give it. See, it will not, 5-10 minutes will not be enough. All, as I already told you very briefly, that quantum framework which was developed in 1920s is now being used to relook at what is computation, how computation can be done, what is communication, how communication can be done. So that is the whole field of quantum information. You're not just dealing with the material or the products developed through quantum mechanics like transistors and so on. You are taking the logical structure of quantum mechanics, which is quite different from the logical structure of classical physics, which requires a talk. I can't tell you that.
So in India, you are always put in a bubble that if you are intelligent, that you should do this or you should get things always right. So how do you get out of that bubble?
I didn't get this one.
Basically, they train you to stop experimenting. So
Stop experimenting. Like they have defined some career fields, like you have to do
I would
engineering.
say that
Yeah.
you all should try to blow this bubble
Yeah.
where you are being pushed in direction A, direction B, direction C, all that. Already, I think you are in IISER, you have broken that bubble because many of your parents would have wanted to see you as engineers or managers. You can still become that, but you have broken the bubble already.
And what is your point of view on the current curriculum?
Which aspect? I am not for pre-major. I think 2 years broad-based training was a good model.
The one thing that I think is bad with the pre-major system is that we got like some subjects were changed. Like we got
to be brought back. Many people in the Senate actually support.
we didn't have electronics in our second semester and we got EES. So I think electronics must have been better because EES is not helping
Yeah,
much.
so my point is that 2 year common curriculum was developed very seriously by inviting all kinds of very important experts, and they had decided that the movement to pre-majors seems to have been done very quickly. I was not party for their decision because I was not here. But personally, I am not for pre-majors because, or you just admit people in a discipline. If you are giving broad exposure, give it for long enough time. Because we even collected data. People came like you guys have come in the new batch. We asked them what you want to do. And then after 2 years we saw that correlation was not more than 50%. Which means that 2 year common curriculum exposure help people to do something else. Lesser you make it and make them people make choices earlier, these choices will be more or less what they came with the idea when they came out of school. So 2 years was a good time to, and no one has came back and told us that you did not give us enough of one subject and I am doing badly in my research because of that. Because I know when you do 2 years, the other argument is that the focus on the subject is little less. That's okay. That gap can be filled, but a broad training gap cannot be filled. You see, if I am, for example, today, if I feel, oh, I don't do enough statistical mechanics, I can read. But today, if I say that I don't know enough philosophy of science, it's difficult for me to go and see what to read, what to do. Or if I say, oh, I don't seem to have learned enough biology, that would be very non-trivial thing for me to figure out what to do, what to read. So, little less effort, emphasis on major, the professional will know. Hardly you will understand that. So that's why I think we should not have cut. Like philosophy of science course apparently I'm told has been cut. That I think is important. If you are not finding, if institute was not finding enough good teachers to teach, that's a practical problem. Try to get a good person to teach. But it doesn't mean that you cross the course called philosophy of science. When curriculum was designed, one course on history of science, one course on philosophy of science, 4 courses in physics, 4 in. This was a 2-year package, very tightly developed. So, yeah, one of the reasons I was also told was that since ES major has to be started, that was not fitting me. One could have done some other way of accommodating ES major than to cut down on these 2 years. So and there should be more discussion with alumni, with students, with people who are currently undergoing education and those who have finished education. So I feel it was done a bit early. My personal view. Of course, I had decided it in a meeting. I was not party to. Even if I was there, maybe the decision would have been taken because I would have just given what I said. But more than saying what I feel it's a somewhat premature decision taken quickly without considering all consequences and all aspects of this. That's my view. Yeah.
Sir, in continuation to this idea, sir, you have mentioned about taking a decision or making a decision tree about your own self. Sir, so, sir, shouldn't this decision tree be postponed or further, like at a later stage after we have done exploration? Because if we focus at a...
Yeah, by the way, in the 2-year, I remember, first 2 year used to be all subjects. Then people used to choose majors. And there are many students who after 6 months wanted to change majors. Many people even changed after 1 year. That was allowed, just that they had to complete credits in a certain way, and some of the courses they had done in one subject were taken as open electives for them and so on. I think there was one student who went from physics to biology and then came back to physics. Some strange pattern of major, or 3 majors he changed. Now he's just finished doing his PhD in economics. He wrote to me today, very bright guy. So bright that he did my course quantum information and quantum computation. So he said, I want to fail. So he did appear in the end. So he got 0 in the end. But he passed the course based on his bits and marks. So he tried failing, but he couldn't fail. That's why I remember it was confusing. Yeah, but yes, I think in any system, for it to be successful, the students should be allowed to not just explore, but also change directions as much as is possible.
Sir, a follow-up.
Yeah.
Sir, if some of us or most of us have come with a preconceived notion about moving in a particular direction or particular field. Sir, according to you, sir, like there is one way of thinking that we are already focused about that particular field and we might be more geared towards that field. But at the same time, there is another discussion that we are not exploring much about the other aspects.
I would go by the second. Even if you are fully focused and thinking of doing one thing, while you are here, do things which are quite opposite to that. What will happen is, either you will change, or your faith and your commitment to what you want to do will become stronger. Either way it will be useful.
Building on to this, I feel like theory is being glorified as well. Like even in our coursework, we are given around like 4 or 5 theory courses and like 2 labs. Like it's a very disproportionate amount. So how would we, and the physics lab work that we do, I don't think it is reflecting what we do in an actual physics lab as well. So how would we?
Yeah, this needs to be changed. I think that is one of the things we have to do at IISER. Because IISERs were to be set up in a way that there is a very strong focus on experimentation. That's why we started developing these experiments. And many of the lab experiments which you are doing, we had put them together over there as a stopgap arrangement in 2007-8-9. But somehow the institutional focus has not been in that direction. And I am not happy with that. Developing science pedagogy, it should be very much part of the activities of faculty here. So my algorithm was very simple. I don't want to boast about it, but more since I was the first person, few of us, me, Kavita, Arvind, 4 or 5 people set up all the first 4 labs. And we set up roughly 10 experiments in each. My idea was when an instructor comes and teaches a lab, please add one experiment which you design. So that in 10 years we have 20, and then we can keep choosing 10 out of those things. But that has not happened. These are the same old experiments, which so instructors have not devoted time to develop new experiments. Maybe they also have limitations, they don't have the time, ability, motivation, but institute should have institutionalized. Now what I am thinking is, if I find time, maybe we should do it instead of criticizing. Let us say that in each physics lab we put at least 2 more experiments in the coming 2 years. At least that will be 20% change. We can start. I already have some ideas. Next time I am teaching a lab. What is it called? Modern 4th semester lab. So we put some new experiments that we design. We can start early also. In December itself we can decide. So some of you who are going to be in that lab, the job can be to add new experiments, which will design after.
We can take up as a project for 5 times.
That's true, but only thing is it requires professional inputs. Our faculty should be, particularly these present faculty should be involved. We should try to bring them into designing experiments. But still, why not? I mean, if student design something, we can take inputs from others, finally put it together as an experiment. But let's design one thing, not too many, at least. We can even say to the student design experiment. I'll tell you an example. Say COVID came, but 2020 I was teaching this lab Anybody from that batch is here? 2020?
I think they're all doing their thesis.
Good, they're not there. So they're nothing like that. So they were young and I was teaching them electricity mechanism labs. And then the COVID came, they all went home. So we decided to design some experiments which can be done at home. So one experiment was, I don't know whether you realize if there's a fan. See, inside fan is a copper coil. The copper coil is conducting. So when you connect the fan, it should be a short circuit. Why is it not a short circuit and why doesn't the coil burn? Anyway, you think about that. So there are something called motor characteristics. So the experiment was to go to motor characteristics. So I said, okay, you open a toy, get a motor. So one student was in Andaman. I don't remember the name now, it was B20 batch. So he or she also, I don't remember. But I got a mail saying that there is nothing here with which I can do this experiment. Finally, that student set up a very interesting experiment. The motor was a blender. And how do we change load when you blend objects with different thickness? So if you blend water, you add some atta to water. So it becomes thicker, becomes more load. So load could be varied by changing the material you are blending. And of course we used the voltage 220 volts which was available in this phone. And more interesting was how to measure current. So you connect a bulb in the series, that is not in parallel, in series, so that depending on how much current is actually flowing, there is a glow. And you use your cell phone as a lux meter to calibrate and measure the current. So the whole characteristics could be done with a cell phone, blender, a bulb, and that was a nice experiment. So what I mean to say is once you start innovating, you can go quite far. Yeah. Will you close at 4? 5? Oh.
Yeah, one more thing added to the lab. Now, labs just feel like they're limited to data collection. We actually go there, we collect data.
No,
We just do the same experience.
My first objection to labs is groups of 3. It should always be group, not groups of more than 2. If IISER cannot afford to have labs of groups of 2, then which college will afford? I think you should put your foot down. No groups of 3. Why? 3 people doing a lab is a joke. I would say one is doing something, other is recording, third one is a non-member. It's not how experiments can be done. Groups of 2 is useful because you need to have some discussion. More than groups of 2, no, you should not accept this treatment.
Sorry, sir, how does an individual in academia also get into policy making?
Well, that's a difficult question. It's not automatic. Not many scientists are into policy making. Policy makers do consult scientists at times in the science policy. Quite frankly, we don't even have a cohesive science policy in the country. Okay, we have not bothered to really have a science policy which is circulated, which is documented, which is approved upon, which undergoes brainstorming. We are not doing any of that. Okay, I don't even know what is the current science policy of the country. Atomic energy has its own goals, somebody else has their own goals, things come back and forth, they get changed according to whims and fancies of certain individuals. So it is not a very organized activity, this science policy, which I think it should. So I really don't know sometimes. I'm consulted, I give my advice. But what is the exact process? I have no idea. I think there's no process. If the policy makers want to consult scientists, they will. If they don't want to consult scientists, they will. That's why I talked about this back and forth. See, for example, now it is being discussed that IISER should be doing translational research. But IISER were not set up to do translational research. So if you have set up institutions to do something, let them do that. And if you want to bring in a certain change, then first do a lot of brainstorming what exactly do you want. It's like increasing seats. You build institutions with classroom size of 250. Now you are saying it with 300 people. So that means you are assuming that 50 people will be absent. What else? Right? So this is not good. One should move in a systematic way on a policy.
Sir, what do you mean translation experiments?
Translational research means research which can be translated to industry, to applications. very quickly.
Um,
Yeah.
Ritvik from MS23. Sir, I have read about, like you talked about Albert Einstein. So we know that he was not a great fan of quantum mechanics because, and I have read about Eddington. So he was a great scientist, but like after he was famous and all, there was a theory. I don't exactly remember the theory, but he was reluctant to accept it, and because of that, that theory was not being accepted within the science community.
Yeah.
So, what is the reason that big scientists
It can happen.
are
See,
reluctant?
you have certain point of view and
Yeah.
you are able to influence with that point of view to some extent. But what has been, like dark matter.
Yeah.
The person who originally thought of dark matter, people called it mad. There's nobody agreed. Name will come to me. So, but in science, at the end, people realize because it is based on certain objective ways of dealing with nature. That's what I told you. In mathematics, it can be much more stronger. One great mathematician can influence mathematics in one direction much more than it can happen in science. Einstein was not unhappy with quantum mechanics, but he couldn't stop quantum mechanics.
And
Eddington may be unhappy with certain theory, he could stop it. Delay can happen. To give you an example, why go that far? See, when Clauser, who shared the 22 Nobel Prizes, so 22 Nobel Prize in physics went for experimental validation of Bell's inequalities, which went to Clauser, Aspe, and Zeringer. So Clauser, when he did these experiments, he was not supported. He did it partly from his own pocket, partly from friends and all that. He set up the experiments in the basement. And department didn't support him. And so much so that they fired him. He didn't get a professor's position anywhere after doing those experiments because people thought these experiments are not important. He has actually mentioned that in his Nobel speech. That physicists have started interacting with me again only after I got the Nobel Prize. So this happens. You know, there must be senior people in the department who said these experiments not important. So this happens.
The same thing happened with Tesla, I guess.
Yeah.
So he was.
So many. But whole idea is that finally I think each sense prevails because science is not a subjective domain. It's a domain which deals with nature. That's what is great about science. Science is standing on its feet. Yeah.
So like you mentioned the case. So how do we differentiate? How do we decide? Like if somebody who has a higher authority than us, he states something. He tells us to do a certain thing. How do we differentiate whether we should accept his point of view or whether we should discard it?
Well, it normally depends on your personality. If you are somebody moving towards becoming a scientist, first think about it. You know, then only see if you accept authority. Most likely, you will also work in the direction of that person's idea. If you reject it and then you are forced to accept it because of logical reasons, anyway you will learn something. And even if you find little flaw, that will be your own discovery. So, when you see authority, at least my attitude is first kind of challenge and defy, then obey. In science. Maybe that person will take first.
So, Stavya from MS24. So, like your fields are very connected. Quantum computing, quantum information are quite connected. But suppose we have interdisciplinary fields which are not as connected, not as strongly connected. We have 3 different fields, for example. And is it possible to be successful in life for 3 of them without sacrificing one?
Well, yes and no. I mean, I would say yes, you have to change maybe the notion of success a little bit. You may have to compromise a little bit. When you join, like I will give you an example very close to me. Professor Kavita, whom I am also married to, she decided to move into and do some research in metabology, which is a very different field from what she had done earlier. And I remember how in the beginning papers were rejected, they would come back with all kinds of remarks because people found that somebody from outside the field is writing, person doesn't know enough botany, so all that and so on. But after some time, she was accepted in that field and now they even invite her for conferences in that field. So it takes, there is a barrier, but the barrier can be crossed. Because metabolomics involves basically biology. So how metabolites can be profiled and what kind of things we can use for. So that's a very different field. So I would see that transitioning was very difficult. And she didn't do a full-time transition. She also wanted to do that. So it can be done. You have to pay some price and you have to cross some hurdles.
So to follow up the question, how can we proceed in the Indian education system? How do we proceed in that?
Well, IISER is a good place. Here, interdisciplinarity is encouraged in every possible way. I mean, I remember there was a mathematics student who did 5th year project with me and Dr. Prasad on the question whether evolution can be reversed. And we did it through computer models. So, you kind of try to reverse the steps in the environment and ask the question whether it is evolutionary process is reversible. And it was an interesting project. So then she moved into that area and she went abroad to do PhD in precisely this kind of area which involves computer science, mathematics, biology. IISER is a good place to do any kind of interdisciplinary work.
Sir, we talked about interdisciplinary research, but isn't modern science so deep? Like people spend their entire lives focusing on one very niche area. Is it realistic to think of doing interdisciplinary research?
Well, that niche question, you're right. So it's like this. When you want to go deeper into a question, that question itself might be interdisciplinary. So the interdisciplinary doesn't mean that you have to divide yourself across disciplines. That's different. Doing more than one thing, your logic applies. That if I do 3 different things, of course I will be able to, I'll have to do. But if I am after a question which is interdisciplinary, then I don't lose focus. Because that question, the nature of the, I go deeper into that question only. And as you said, science is deep and at the end you are competing with the 2 people looking at that question. But if the question is interdisciplinary, then of course there is no other choice.
But then you would have to look, you would have to have a certain interdisciplinary lens to look at the world.
Precisely. So you need, that is what is important. If you don't have that point of view, you will not be sufficiently apt to be able to actually go deep into the question. Yeah.
When I following on this, when I came, when I joined MSmet, I saw 2 kinds of people. Like some people were used to think a lot, and people used to solve a lot. Like you see this guy and it's like, oh wow, this guy is a very good thinker. And there's another guy who was taking 70 problems and one topic and solving the whole thing. And one guy who was just taking one small question and thinking about it full time. So, how much of both is
very good point. See, point is in physics there is no escape from solving. There is no escape from thinking either. But many people see, after all, if you are not doing a large number of problem solving, you yourself will not fully know how well you have thought and worked with the physics concepts. Physics is such a discipline in which solving problems is very important. So the thinking will get validated only when you solve problems. This is what is the nature of it. Both are important. But solving cannot be, just because I can think a lot doesn't mean that. There is one of my students, the BSML student, even wrote a paper from his 5th year project, learned this the hard way. So, he would intuitively, so he did something which was completely wrong. And then he was not willing to accept that it was wrong. Because he had some way of thinking through it and it looked right. So we actually calculated it. So at the end, if you want to become a physicist, whether experimental or theoretical, please do not spend some time solving problems. Because solving problem, not some plugging in numbers, problem, well-posed problem when you engage with, that in some sense influences your thought.
Going away from this topic a bit, I have a question related to science only. So there is a hot topic going in between quantum physicists and astrophysicists, quantum gravity stuff. So what do you think about that? Why are people trying to find the particle called graviton? Why are they so excited about it?
Well, I'm not an expert in that area, but the problem has been around because if quantum mechanics explains everything and it is a fundamental way of looking at the world, it should also be able to combine with gravity, because gravity is important in the universe and gravity also acts at very short scales and so on, where quantum mechanics is important. But there have been many difficulties in combining the two. Currently some progress has happened, but I have not really paid attention to that. But it is important to have a quantum way of thinking.